What's up everyone, it's Stack Lessons here. Welcome back to the channel. Today we're diving into Amazon Web Services Glue ecosystem, Flex, DataBrew, data quality, and beyond. Let's get into it. By the end of this video, you'll know exactly when to reach for each of the 5 lesser-known Glue features the exam loves to test. And you'll never again confuse DataBrew with Lake-Formation. That last distinction, by the way, is the single most tested trap in the entire Glue domain of the Amazon Web Services Certified Data Engineer Associate exam. Quick recap from Episode 2. We covered the Glue data catalog, the central metadata library that Athena, EMR, and Redshift Spectrum all read from. We covered crawlers, which automatically discover schemas using a priority-ordered classifier chain. We covered ETL jobs, the serverless Spark engine with dynamic frames and resolve choice for handling messy data. And we covered job bookmarks, the state tracking mechanism that stops you reprocessing yesterday's files. That was the foundation. Today we cover the rest of the ecosystem, which is where the exam quietly hides some of its highest value questions. Most courses spend a full hour on crawlers and then breeze past the rest of the Glue family in 2 minutes. That's a mistake. The exam writers know candidates focus on the core, so they pull questions from the periphery. Today we're covering 5 features most courses skim, plus 1 networking scenario that shows up so often, candidates on Reddit call it nearly guaranteed. Let's start with the easiest cost optimization win in all of Glue. According to the official Amazon Web Services Glue product page, Flex is an execution option for non-urgent ETL workloads, and it cuts costs by up to 35%. That number, 35%, is worth memorizing, because the exam will use cost optimization language to point you straight at this feature. Here's the easy way to remember it. Standard is a confirmed flight booking. You pay 44 cents per DPU hour and your job starts when you ask it to. Flex is a standby ticket. You pay only 29 cents per DPU hour and you get the exact same plane and the exact same seat, but you can't guarantee when you'll take off. So if your job has a strict service level agreement, like an hourly extract feeding a production dashboard, you stay on standard. But if it's a nightly backfill, a dev environment, or a one-time historical reprocess, Flex is the obvious answer. Lock these trigger words into memory. If you see non-urgent, cost optimization, development or test environments, or flexible service level agreement attached to a Glue job, the answer is Flex Execution class. Amazon Web Services gives a concrete example in their docs. A 60 PU job running for 20 minutes costs 88 cents on standard, but only 58 cents on Flex. That's the 34% in action. Now meet DataBrew. This is Glue's visual point-and-click data preparation tool, and the first thing to internalize is who it's built for. Not data engineers, analysts. People who know what the data should look like but don't want to write PySpark to get there. DataBrew ships with over 250 pre-built transformations, which is a number worth remembering because the exam uses it as a signal. It also has built-in PII detection and redaction recipes, so an analyst can hash a social security number column or shuffle names without ever opening a code editor. There are 2 job types you should know. Profile jobs analyze your data and tell you what's in it, and recipe jobs apply a sequence of transformations and write the result back out. And here's the key word for the exam. DataBrew changes the data. Burn that into your brain. The next slide is the trap. Here it is, the single most tested distinction in the entire Glue domain. DataBrew transforms the data itself. Lake-Formation governs who is allowed to access that data. They are not competing services, they are complementary layers. The exam will absolutely write a question where Lake-Formation is the right answer and DataBrew is the seductive distractor, or the reverse. If you walk out of this video remembering only one thing, make it this one. Picture a restaurant. DataBrew is the chef in the kitchen. The chef chops, cleans, and seasons the ingredients. The food itself physically changes shape, color, and composition. That's what DataBrew does to your data. Lake-Formation is the maitre d' standing at the door. The maitre d' doesn't touch the food. The maitre d' decides which guests are allowed in, which rooms they can enter, which tables they can sit at. That's permissions, row-level access, cross-account sharing, GDPR, and HIPAA controls. The chef acts on the data. The maitre d' acts on permissions. One transforms, the other guards. Here's your keyword decoder. On the DataBrew side, watch for no-code, visual interface, data preparation, business analyst persona, PII masking, or that magic number 250 transformations. On the Lake-Formation side, watch for fine-grained access control, row-level or column-level security, GDPR or HIPAA compliance, cross-account data sharing, and centralized permissions. Read the qualifier carefully, because the question stem will usually contain exactly one of these phrases pointing you to the right answer. Moving on to the third feature, Glue data quality. The official docs put it this way: DQDL is a domain-specific language for defining data quality rules, and the whole service is built on top of the open-source DEAC framework. DEAC was originally developed by Amazon for internal use on Amazon.com product data, so this is battle-tested technology. The big idea is data quality as code. You write declarative rules in plain English, and Glue enforces them inside your pipeline. Read these rules out loud and notice how human they sound. Row count greater than 1 million. Completeness of the user _ID column greater than 99%, meaning at least 99% of rows must have a non-null user ID. Uniqueness of event ID greater than 99.9%. Column values for country must be in the set US, CA, or MX and referential integrity, meaning every product ID in this table must exist in the catalog products table. This is like writing TS a checkpoint rules in plain English, and the Glue job is the security officer that enforces them. Here's how this plays out in a real pipeline. Imagine Nexer Retail's marketing team ingesting ad impression data. Step 1, ingest the raw data from S3. Step 2, transform Glue ETL applies business logic. Step 3, validate the data quality node evaluates your DQDL rules right in the pipeline. Step 4, branch, pass flows to Redshift, fail pages the team. Step 5, publish, only clean data ever reaches downstream consumers. The corrupt rows never make it to the dashboard, which is the whole point. Feature number 4, find matches. Straight from the docs, this is a transform that finds duplicate or matching records even when there's no shared key and no fields match exactly. And critically, it requires no code and no machine learning expertise. This solves a problem that deterministic joins cannot solve. When the same customer appears in 3 systems with 3 slightly different spellings of their name and address, a SQL join on email will miss them. FindMatches catches them. First, label. Glue generates labeling files with about 100 records broken into small tasks, and you mark which pairs match and which don't. Next, train. Glue learns a model from your labels. This is supervised machine learning, not magic. Then tune. You slide a precision versus recall control to decide whether you want to catch more matches at the cost of false positives or be stricter and miss a few. Then apply. The train model runs across millions of records. Finally, output. Each row gets a match _ID tag, and you pick which record to keep as the survivor. Think of it like teaching a new hire what counts as the same customer. You show them a batch of examples, they learn your judgment, and then you scale that judgment to millions of rows. For modest match quality, Amazon Web Services recommends labeling a few hundred records. For high quality, a few thousand. This is the canonical example. John Smith at 123 Main Street and Jonathan Smith at 123 Main Street spelled out. Obviously the same person. No deterministic join in SQL can connect them. Nexer Retail might pull customer records from Shopify, Salesforce, and an old MySQL CRM with no shared key anywhere. They train FindMatches on 500 labeled pairs, run it across 50 million records, and out comes a unified customer table. That's customer 360. The exam loves this scenario, and the trigger words are fuzzy matching, no common key, or customer 360. Feature number 5, Glue Schema Registry. This service lets you centrally discover, control, and evolve schemas for your streaming data. It's serverless with no infrastructure to manage. It's completely free to store and validate schemas. There's no cost to register schemas or to validate against them. And most importantly, it enforces a contract before bad data ever enters the stream. Schema Registry exists because streaming pipelines break in subtle ways when producers and consumers disagree about the shape of the data, so the contract is enforced upstream. The producer on the left, maybe a Lambda function, prepares to publish an event. Before it can write, the data flows through Schema Registry, which validates it against the registered contract in Avro, JSON schema, or protobuf. If the data violates the contract, the producer fails fast and the bad bytes never enter the system. If validation passes, the event lands on the stream, whether that's MSK or Kinesis data streams. The consumer reads from the stream knowing the data shape is guaranteed. Producers and consumers share an enforced contract. Compatibility modes are where most candidates get tripped up, so slow down here. Backward compatibility on the left means a new consumer using the new schema can still read old data written with the old schema. This is the most common mode in practice. It's safe to add optional fields or remove any field, but it breaks if you add a required field because old data won't have it. With backward, you upgrade consumers first. Forward compatibility on the right is the mirror image. An old consumer using the old schema must be able to read new data written with the new schema. Safe to remove optional fields or add fields, breaks if you remove a required field. With forward, you upgrade producers first. 2 facts worth memorizing. There are 8 compatibility modes total, but in practice, everyone uses backward, forward, or full. Full means both directions work simultaneously, which is the strictest and safest mode. The other 5 modes are edge cases. And second, the entire Schema Registry service is free. No charge to store schemas, no charge to validate. So if you see a question about streaming data governance on a budget, this is your answer. Okay, time for the section that pays for this entire video. The VPC scenario. Candidates on Reddit who passed the Data Engineer Associate exam report seeing this exact question, sometimes more than once. And on Amazon Web Services Ray post, the same question appears hundreds of times in practitioner threads. If you understand the next 3 slides, you'll get this question right. Guaranteed. Here's the exact error you'll see in the logs. The job starts up fine. Glue acquires an Elastic Network Interface, or ENI, in your private subnet. The ENI gets a private IP, in this case 10.0.2.47, with no public IP assigned. The job tries to read from S3 and then boom, VPC S3 endpoint validation failed, unable to connect to S3, connect timed out, job state failed. This error message is so common that Amazon Web Services has an entire dedicated Ray Post Knowledge Center article for it. So why does this happen? The next slide answers that. Here's why this happens straight from the docs. When Glue runs in a VPC, it creates elastic network interfaces inside your subnet. Each ENI gets a private IP from your subnet range. No public IP means no path to S3 over the internet, even though S3 is normally accessed that way. So you need a private path from the subnet to S3, and that private path is the gateway endpoint. This is the key insight. Glue's networking inside a VPC is private only, which is exactly what makes the gateway endpoint the right and only answer. Think of it like a private elevator to Amazon's warehouse. Your Glue job sits in the private subnet with an ENI holding a private IP next. You create the S3 gateway endpoint inside the VPC, and it's free. Then you add a route table entry mapping the S3 prefix list to the endpoint ID, and you associate that route table with your subnet. After that, traffic flows straight to Amazon S3 over the Amazon Web Services private network, never touching the public internet. Compare that to a NAT gateway, expensive, noisy, and routing through the public internet. The gateway endpoint is free, faster, and stays inside the building. 3 details you must get right. First, create a gateway endpoint, not an interface endpoint. Gateway endpoints are free for S3, and DynamoDB interface endpoints cost about a penny per hour per availability zone, which adds up fast. Second, associate the endpoint with the route table of every subnet your Glue job might run in. Multi-AZ setups are where teams trip up because they configure one subnet and forget the others. Third, gateway endpoints only route to buckets in the same region. If your S3 bucket lives in a different region, you still need a NAT gateway. Bonus detail: your Glue connection security group needs a self-referencing inbound rule allowing all TCP traffic from itself. This lets the Glue ENI communicate on the Amazon Web Services private network without a NAT gateway or internet gateway. Get those right and traffic flows over the Amazon Web Services private network with no public IPS, no internet gateway, and no egress charges. Let's put real numbers on this. Standard Glue running a 4-hour nightly job costs about $14 per night. Switch to Flex Glue and the same job drops to about $9 over a year. That's roughly $1,800 saved on a single workload. Now endpoints. The S3 gateway endpoint costs exactly $0 per month. The S3 interface endpoint for the same access runs about $7 per month per availability zone, and you typically need 1 per Z. So Flex plus gateway endpoints together can shave thousands off a single team's Glue bill, which is exactly the kind of cost optimization scenario the exam loves. Rapid-fire keyword to service decoder. No-code data prep or analyst cleaning data points to DataBrew. Row-level access, GDPR, or cross-account sharing points to Lake-Formation. Non-urgent or cost optimization points to Flex execution class. Fuzzy matching with no common key points to FindMatches. Schema evolution or streaming contract points to Schema Registry. And Glue can't reach S3 from a private subnet points to an S3 gateway VPC endpoint. Pattern match these phrases on exam day and you'll save yourself a lot of thinking. 7 things to lock in. Flex 34% off non-urgent jobs. DataBrew changes data 250 transforms PII recipes. Lake-Formation controls access fine-grained governance. DQDL declarative data quality on DEC. FindMatches fuzzy dedup from labeled pairs no shared key. Schema Registry free streaming schema versioning backward is the default mode. And private subnet Glue plus S3 means an S3 gateway endpoint in the route table, period. That's the answer every time. Now let's see how well that landed with a quick 5-question quiz. Question 1. A data analyst at Nexer Retail needs to clean customer CSV files and mask social security numbers before loading them into Redshift. She has no coding experience but knows exactly what transformations she wants. Which service is the best fit? Is it A, AWS Glue DataBrew with a PII redaction recipe? B, AWS Lake-Formation with column-level permissions? C, AWS Glue ETL job with a custom PySpark script? Or D, AWS Glue data quality with DQDL rules? Take a moment to think about it. The answer is A. DataBrew is purpose-built for no-code data preparation by analysts, with over 250 transformations including PII redaction recipes. Lake-Formation controls access but doesn't transform data. ETL requires coding, and data quality validates rather than transforms. Question 2. A Glue job running in a private subnet fails with the error VPC S3 endpoint validation failed when trying to read from an S3 bucket in the same region. What is the most cost-effective fix? Is it A, move the Glue job to a public subnet with an internet gateway? B, create a NAT gateway and route the subnet traffic through it? C, create an S3 gateway VPC endpoint and add it to the subnet's route table? Or D, create an S3 interface VPC endpoint in each availability zone? Take a moment to think about it. The answer is C. Glue elastic network interfaces only have private IPs, so an S3 gateway endpoint is the correct fix. Gateway endpoints are free and work for same region S3. A NAT gateway technically works but costs money. A public subnet doesn't help because Glue's EN is don't get public IPs. And interface endpoints cost money and are unnecessary for same region S3 access. Question 3. A retailer needs to deduplicate customer records pulled from Shopify, Salesforce, and a legacy MySQL CRM. The systems share no common identifier, and names and addresses have slight spelling variations. Which AWS service solves this? Is it A, Glue ETL with a SQL join on email address? B, Glue FindMatches ML Transform trained on labeled pairs? C, Glue data quality with a uniqueness DQDL rule? Or D, Lake-Formation with row-level filtering? Take a moment to think about it. The answer is B. FindMatches is specifically designed for fuzzy matching when no shared key exists. You label about 500 example pairs, and the model learns the pattern, then deduplicates millions of records. SQL joins fail without an exact match. Data quality validates but doesn't dedupe. And Lake-Formation controls access, not record matching. Question 4. A fintech publishes transaction events to Amazon MSK using Avro schemas. The team wants to prevent producers from publishing data that would break downstream consumers when a new required field is added. Which configuration achieves this? Is it A, register the schema in Glue Schema Registry with forward compatibility? B, register the schema in Glue Schema Registry with backward compatibility? C, use Glue data quality with a completeness rule on the new field? Or D, use Lake-Formation column-level permissions to block the new field? Take a moment to think about it. The answer is B. Backward compatibility means new consumers must be able to read old data, so adding a required field is rejected because old data wouldn't have that field. This protects existing consumers. Forward does the opposite, keeping consumers on the old schema. Data quality validates rows, not schema evolution, and Lake-Formation governs access, not schema contracts. Final question. A Glue ETL job in a private subnet is failing to read from an S3 bucket in the same region. The team has already created an S3 gateway endpoint in the VPC. What is the most likely remaining cause? Is it A, the job needs a NAT gateway to reach S3? B, the gateway endpoint must be converted to an interface endpoint? C, the Glue connection security group is missing a self-referencing inbound rule? Or D, the root table of the jobs subnet has no entry for the gateway endpoint? Take a moment to think about it. The answer is D. A gateway endpoint only works once you add a root table entry mapping the S3 prefix list to the endpoint ID, and that root table must be associated with every subnet the Glue job runs in. A NAT gateway is not needed for same region S3. Interface endpoints would work, but they cost money and aren't required here. And the self-referencing security group rule matters for glue-to-glue traffic, not S3 access. Nicely done. You now know the 5 Glue features that hide on the periphery of the exam, and you know the VPC scenario cold. Next episode, we go deep on Lake-Formation itself, the governance half of the equation. Row-level security, column masking, cross-account sharing, and how it sits on top of the Glue data catalog you already understand. And because you've watched this episode, you'll never confuse it with DataBrew again. See you there. And that's a wrap on Amazon Web Services Glue ecosystem, Flex, DataBrew, data quality, and beyond. If this helped you out, smash that like button and subscribe for more. See you in the next one.